In this lecture, we're just going to talk briefly about what an algorithm is. It's expected that you have a background and familiarity with algorithms coming into this class. For us, an algorithm is going to be a principled way to generate output from input. Remember, in our combinatorial problems, we have some input, we have some output. An algorithm is going to manipulate our input to get the proper output. Here we have an example algorithm for our knapsack problem, and in this case it's written in pseudocode. Pseudocode is just some code-like way to describe our algorithm. In our pseudocode, we have a set K, initially equal to the empty set, that's going to be our current best set. It's going to be the set with the highest value that satisfies our constraints. We also have a parameter V, initially equal to 0, and V is going to be the value of our current best set. The idea behind our algorithm is that we're going to look through all the sets, so every subset of items, and we're going to update our current best set as we go through these different sets S. To update things, we're going to first compute two values. We're going to compute the value S to look at the size of all of the items in our set S, and we're going to look at V bar. V bar is going to be the value of set S. And if it turns out that our set is feasible, that is, the size of our set is less than C, it can fit into our knapsack, and if V bar is greater than V, that is, if the set we're looking at has a higher value than our current best set, then we're going to update our current best set. That is, our current best set is going to be this new one, this one that we're looking at, this set S. And we're going to look through all the sets S, and every time we do, we're going to update our current best set. At the end, we'll have the best set, and we're going to return it, and that should be at the value K. This is pseudocode, and this is an excellent way to describe algorithms. Unfortunately, this is nothing like what we'd like to see in this class. In this class, we're going to take a simpler approach. Instead of writing pseudocode, managing where things are going to be and updating variables, we just want to get the main idea across. So when writing an algorithm, think just get the idea across. For example, in this knapsack problem, we already said what the idea was. We're going to compare every set in N, or every subset of items, and we're going to take the subset that has the largest value that still fits inside of our knapsack. That is, the sum of the SI's is less than or equal to C. We can describe that entire algorithm with this one sentence. This is sufficient and actually desirable. You're getting the main idea across without all the junk of the pseudocode. For this class, this is what we want.